Hello everyone. So today we're going to go through triangles, and we've been dealing with 45, 45, 90 and 30, 60, 90 triangles, but this time we're going to be dealing with triangles that don't fit into that special triangle category, but they are still right triangles. So here's the first problem that we want to talk about, okay? So when a rocket is launched, it climbs 50 feet. For every 13 feet, it travels horizontally. So automatically you can think, this looks like slope, right? It reminds you of slope. Climbs 50 feet, goes up 50 feet. For every 13 feet, rise over run, right? Travels horizontally. Draw a diagram to represent the situation. So in order for you to solve this problem, you have to draw the diagram, and then you have to estimate the rocket's launch angle. And so in order for you to solve this, you actually need to use this tool, okay? And this tool will help you estimate the different angles for the right triangles. So I'm assuming that you guys tried this problem out. So this is what the diagram should look like, okay? So horizontally travel 13 feet. Was it 13 feet? Yeah. And then vertically it traveled 50 feet, right? So 13 is my rise or my run, and then 15 is my rise. So as you guys can see, if following this pattern, my degree angle is going to be 75 degrees. So how did they get 75 degrees though, right? So we have to use this tool for us to estimate what that diagram is going to look like. So if you take a look, it's going to be 13. So I'm going to go, that's like -10. And that's about, I don't know, let's do it deeper. So that's about -13, right? So if you take a look right here, yeah, so that's -13. Take a look, that's about -13. It doesn't have to be perfect, right? It just has to be somewhat accurate. So -13. And then my height is 50. So my height is going to be about 50. Rise that up. About 50 like here. Okay, so that seems about right. If you guys can see, it's about 74.905, which is about 75 degrees, right? So this triangle is similar to this triangle, and therefore the angle also is accurately described here, which is 75 degrees, okay? All right, so now let's take a look at this problem here. Same thing, right? Now, before we found the angle, now we want to find the length of AB. Okay, how do we find the length of AB? You need to use this tool again. So let's draw it. So we're going to get 20 degrees. So we're going to get 20 degrees. So you guys see that's about 20 degrees. And the hypotenuse is going to be about 8.5. Okay, so the hypotenuse is going to be about 8.5. So that may be, so if this is like, all right, let's go a little closer. So if this is like 8, right, the hypotenuse is going to be about, it's going to get a little bit less, right? The length is going to remain the same. It's about 20 degrees. So I think maybe the hypotenuse here is going to be about 8.5, okay? It seems like it might be about the same, okay? So we're all estimating here, right? You don't have to get super accurate with this stuff right now. But at this point, we can guess that this is about 8.5. 8.5 would be like right here, right? You guys see? So that would be 8.5. If we just, estimate it up to the 20 degrees, it's going to be around here, okay? So that's about 8.5, and then we got 20 degrees, right? So what is the length of AB? Length of AB. So the length of AB, it should be about 8 units, okay? So we're a little bit off, but that's okay. So it should be about like that, okay? So it should be about 8 units, right? So if we take a look at this length, right? This is going to be about 8.5 from here to here. We're just estimating, and we get about 8 units for this, these values down here, okay? All right, let's go to the next problem. So we got number 2, okay? In a right triangle with one angle measuring 40 degrees, the leg opposite of 40-degree angle is 5 centimeters. What is the length of the hypotenuse? Okay, so let's take a look. So in a right triangle, one angle measuring 40 degrees. So one angle measuring 40 degrees right there. And the leg opposite of that angle is 5 centimeters. 5 centimeters. And yeah, and we know that this is a right triangle. It's a right triangle. So we got 40 degrees, and then this is 5 centimeters. How did I get 7.8, right? So we have to use the tool again. So we go here, right? And then we go boom, boom. Let's go to about 40 degrees, right? So that's about 40 degrees. And we need to get it 5 centimeters. So we got to get it 5 centimeters high. So that's about 5, right? That's 5. So that's about 5 right there. 40 degrees, 5. And then we have to see that this right here, this length is about 7.8. How do I get 7.8? So what we can do is we can get this length right here, right? Okay. This length is about 6. This is about 6 squared, right? This is 6 squared plus, that's going to be 5 squared is equal to c squared, right? C squared. So what we can do is 6 squared is 36 plus 5 squared is 25 is equal to c squared, and 36 plus 25 is equal to c squared, and then 36 plus 25 is about, what is it, 71? No, 61. Yeah, is equal to c squared, and then square root, and then you got square root of 61 is equal to c, okay? So what is square root of 61? Okay, let's take a look. Square root of 61 is about 7.8, okay, which is 7.8, voila. That's what we got here, right? So you want to be able to use this tool, right, to be able to find the length of the hypotenuse for this case. And then you could use the Pythagorean theorem as well, okay? All right, let's try this one, okay? What is the length of segment DE? So we have to find this length right now, okay? So what I'm going to do is we got 50 degrees. So this is going to be a little bit confusing. Actually, let's see if I can make, yeah, there you go. So we got to make it 50 degrees, 50 degrees, 50 degrees, voila, 50 degrees. And then this is going to be about, that length is going to be about 6. So that's going to be 6. All right, so that's about 6. But I got to keep it 50 degrees. I got to keep it 50 degrees. 6, but I got to keep it 50 degrees. 50 degrees right there, okay? And then what is the length of DE? What is the length of DE? So if this is 6, then DE is going to be corresponding to this length. And that length is about 7.6, about 7.6, 7.2. 7, that's about 7, yeah, that's right, 7.2. So that's 7.5. That's going to be about 7.2, 7.3 right there, okay? Which is pretty accurate. And my answer is 7.2 units, okay? All right, let's try this one. In a right triangle with one angle measuring 70 degrees, the leg opposite the 70 degrees angle is 12 centimeters. What is the length of the leg adjacent to the 70 degree angle? A leg adjacent means next to, okay? So we got 70 degrees, right, like this. And the leg opposite of 70 degrees is 12 centimeters, right? Leg opposite of 70 degrees is 12 centimeters. And this is the leg adjacent to 70 degrees. So we had to find this length, and which we find that is 4.4. But how do we get 4.4? So what we're going to do is we're going to go here. And we're going to make this 20 degrees, right? So we're going to make this 20 degrees. 20 degrees. Because if this is 70, this has to be 20, right? Because 70 plus 20 must equal to 180. And then we're going to go 20 degrees. Okay. And then the length of, or the base is 12. So we're going to go all the way to 12. 12 with 20 degrees. 12 with 20 degrees. Okay, that's about right. And so what is the height? Okay, so what is the height? So we got 4 that's about 4.5. Okay, so if this is 4.5, it looks like it's about 4.2, right? But I got 4.4, which is pretty close enough. Okay, 4.4, 4.3, 4.2. If you get any of those answers, it's pretty good. Okay. All right, let's go to the next problem. Okay, actually, no, that's it. Okay. So basically the main takeaway for this is that you want to be, as long as you know the angle and you know one side, you can find all the other angles and all the other sides using this tool. Okay. So whatever angle you're given, one angle and one side, using this tool, you can find any measure, length or angle wise here. Okay. So I hope that helped, and I'll see you guys in the next video. Okay, bye-bye.